So working through a few questions here. The first one is just ask for monochromatic light following on two slits that are 18 micrometers apart. They produce a fifth order fringe with an angle of 8.6 degrees. What would the wavelength of the light used be? So here's the image that I drew where here's my two slits. Here's the screen where those lights going to come together here. And this is my m equals 0, and then would be my fifth order fringe. Now the angle that they make here, which is the length from the slits to the screen, and then from the slits to that fifth order, is 8.6 degrees. So it asks for simply the wavelength of the light used, and so what I can do is I can use my equation d sine theta equals m lambda. I can solve for lambda because d is given, the angle sine theta is given, and then m is going to be my fifth order fringe. So that's how I would set up that first problem there. The second problem says the third order bright fringe of 610 nanometer light is observed at an angle of 31 degrees when the light falls on two narrow slits. How far apart are the slits? So basically what we're trying to find is we're trying to find D in this case. Okay, so I know my wavelength 610. Here's my slits. Here's my wave incident light. It goes through two small openings, so we have two wave fronts, and the angle that gets produced from the central maximum to the third order is 31 degrees. So m equals 0, m equals 1, m equals 2, m equals 3. The equation I can use is d sine theta equals m lambda. I can then solve for d by taking m times lambda and divided that by sine of my angle, 31 degrees. Third one here says a little bit harder of a question, but it says two different types of light. So it's 720 nanometers, 660 nanometers, passes through two slits, and the slits are 0.62 millimeters apart. How far are the second order fringes for these two wavelengths, how far apart on a screen 1 meter away? So the idea is, here's my slits. I have a distance d, which that's my 1 meters of a screen. The central maximum, those two lights are going to line up, and so they're going to all be in the same location. Then, as those lights, because they have different wavelengths, from the equation d sine theta equals m lambda, they're going to have a different angle. So there's going to be two different angles when we get down to this second order fringe. The lights are no longer going to be overlapping, but they're going to start spreading apart. So d sine theta equals m lambda. Because there's a different wavelength, we're going to have a different angle. M is going to be the same. D, the openings are going to be the same as well. So how would I do this? In my setup, I basically am calling the red color 1, the yellow color 2. Not necessarily exactly what it would be, but just give you an idea of how I work through this. Theta 1 then is the angle that the setup, this distance here of 1 meter, and then how far it is from the central maximum. That angle is theta 1. Theta 2 would be for my yellow color here. Okay, and basically the goal of this is trying to find delta x, right? How far are they apart at the second order maximum? So how I would walk through this is first I'm going to find theta 1 and theta 2. Okay, to do that I'm just going to use d sine theta equals m lambda, solve for theta 1, theta 2, the inverse sine of m theta 1 divided by d, or m theta 2 divided by d. So that would give me my two angles, theta 1, theta 2. Okay. Then what I can do is I can find x1 and x2. x1 is how far is this second order fringe from the central maximum. And I can do that from this triangle that's made here. Okay, I know this side is d, that's 1 meter. I can solve for this length here, x1, because I know this angle here. So I'm going to use the tangent of that because this is the adjacent side here. D is the adjacent side, and then x1 would be the opposite side. So tangent of theta, which I just solved for over here, would be x divided by d. And so then x would be d times the tangent of theta. So once I found my angle, I can work through the problem. The last part then is what is delta x? Delta x is basically x2 minus x1, right? So that's going to be how far I have left in between them. And to work through that, without any numbers, I would plug in, okay, delta x is d tangent theta 2 minus d tangent theta 1. And this becomes a lot. Now, there's maybe a better way to simplify this. I don't have my sine, cosine laws memorized, but basically we have d tangent, the inverse sine of this minus the tangent inverse sine of that. And that's going to give me how far apart they are. But so hopefully what we can see is that all of these, we're basically setting up an image that looks something like this. We're figuring out, okay, which order maximum are we dealing with? And then understanding that, again, this angle here, it corresponds also with the angle of the length difference for the two light sources coming out of either of these slits.